Hello, this is Roger Bisbee from the Skill Builder channel, and we are joined this week by Byron Lawson, who is an expert on multifoils. We've had a lot of questions about multifoils, and a lot of people are wondering whether they're a good alternative to more conventional, more traditional means of insulation. And Byron has got the answers to all our questions, I'm absolutely sure. Byron, your job is a technical manager, is that right?
That's correct, yeah.
You represent SuperFOIL, but we're going to talk generally about multifoils anyway, as a generic, but obviously you're going to represent your company and what you've achieved in the development of multifoils.
Well, so as a company, we probably have the greatest range of multifoils, certainly have the highest performing multifoils of any manufacturer.
We don't want second best, so we've come to the right person. So can you just tell our viewers, because some of them are trade, but some of them aren't, some of them are homeowners, they may not know what multifoils are. So if you can just give us a brief overview of what they are.
As their name suggests, multi-layer foil, they're products which are made up of multiple layers of differing material. The outer layers will always be a high or a very low emissivity surface, foil surface, because that adds to the thermal value. But the in-between layers are a combination of MPET, which will be a plastic with foil on. It will be loft material, which tends to be a blown polyester or something like that. So it's a wadding type material. Some products have a thermofoam as well. So each product is made of a multiple layers of these materials. Those materials, once installed, also trap air, but the nature of the surfaces and the materials mean that they add value to the overall thermal performance of the material itself, by their ability to offer this low emissivity surface, which is able to radiate energy.
To put it into layman's terms, this is a shiny foil that is radiating heat back into, well, it can work either way. Obviously, it can work to keep heat out if it's in the summer and it's a loft conversion or something, or it can keep heat in if you're heating your house and it's cold outside, because heat is always traveling to cold. I think we ought to just say that. That's the way it always goes.
Yeah, it always moves in one way.
You've got several layers of foil there. Several, up to 10 in your case, I think, in your products.
Well, right? If you look at SF60, which is our sort of top of the shop at 100 ml in thickness, there are actually 55 layers in that product. SF40, 37 layers. They all started with SF19 at 19 layers. So, there are multiple layers, but different products have different structure. Our original product, SF19, had 19 layers. SF19 Plus is a derivative SF19, but it is a higher performing product, and actually it has fewer layers.
Oh, really?
So
it gets even more confusing.
It's about the nature of the buildup of the material, and the way in which they're combined. So you find that more foil and wadding have a better performance than multiple layers of many different materials.
So if we're looking at a piece of foil, for example, and we've got heat going through, now heat's going through radiation and also through conduction, yeah? So
conduction,
it goes through the first piece of foil, then it hits a different material. The interleaf between two bits of foil is something which stops the conduction. Is that right?
It interferes, it interrupts, so it reduces. Okay. What you're explaining there is, in fact, one of the reasons, because the foils are made up of multiple materials. Each one of those materials has its own thermal conductivity. Most traditional insulation products are always badged with a thermal conductivity. Mineral wool, for example, from 0.32 for a high performance to 0.44. PIR boards around 0.22. They state a conductivity. It's a homogeneous product. It's the same material all the way through. So we can measure conductivity. For multi-layer foils, we measure their ability to resist the passage of heat. Rather than to conduct energy, we look at the resistance. So you will always find multi-layer foils sold on their R value, their thermal resistance, rather than their lambda value.
I understand, yeah. By putting these multi-layers in, the heat is going through the first layer, and as you say, it's impeded, it's disrupted. When it goes through the second layer, the idea is that every subsequent layer it goes through, it's losing a little bit of energy, and hopefully by the time it gets to the last layer, there's hardly any of it left.
Exactly. You're retaining the heat. So it's the same as in any insulation. It's the difference is, I say, instead of measuring the speed at which it conducts through, we're saying that how we slow it down, the resistance.
All right, that's good. Okay, so now my next question is, what is the advantage of this? Why don't we just put in a load of, thermals or rock wool or fiberglass quilt, that kind of thing?
Well, one of the sort of key elements is the overall thickness that you require to achieve the same level of insulation. You talk about mineral wool. Thermal conductivity of 0.044 means you've got to have substantial thickness to achieve a manageable or a targeted thermal value. If you're working to building regs, for example, 0.18, which is the U value in a roof, then you need a substantial depth of mineral wool to do that. So we can, by using a multi-layer foil, which has this core thermal value, this core resistance value, that you can add on to the additional benefit that the foil surface brings by its low emissivity and its ability to radiate energy, which means that an airspace adjacent to a low emissivity surface increases in its thermal value. Mathematical calculation, but so the foils installed with an airspace can achieve a higher thermal value than if you had the same amount of mineral wool, the foil would substantially beat it in terms of its thermal performance. You're leading to thinner buildups.
Okay, so when you say the same amount, you're talking about the same thickness, are you? If you had the same thickness,
if you had the same thickness of mineral wool to foil, the foil would outperform that thickness of mineral wool. Okay,
so I'll just go back slightly, maybe 20 years or so, when I remember when...
I might not remember that far back.
You definitely won't, but when the multifoils were in their infancy, if you like, I went to a couple of do's, where they were launching products and so on, and they were making extravagant, or what I considered to be quite extravagant claims for these multifoils, and I kind of, challenged them a little bit on it, and as did other people. They weren't able to substantiate the claims back then. They were saying that, putting a layer of this multifoil in would be equivalent to, 8 inches or 200 millimeters of fiberglass quilt. And I said, well, how are you proving that? And they were talking about a hot box test to prove it. And that was running into all kinds of difficulties. They said, look, we'll get back to you on this once we've devised the proper test for multifoils, because they were saying that we can't use the same test as you use for other types of insulation. They never really got back to me. And I kind of have given them a bit of a swerve for many years because I've never really seen the evidence of how well they work. And I'm assuming now that the evidence is there because obviously you've had them accepted by building control, so they must be persuaded that there's some evidence to back this up.
The evidence that is there is that we test according to the UK building regulations and the methodology they require us to use. So all of the testing which is done on SuperFOIL products follows the direction of BR443. There is a separate standard as well, an international standard, EN 16012, which stipulates, depending on the structure of the product, it could be a foil-faced product with bubble insulation, a foil-based product on a plastic or whatever. There is a different methodology set out in EN 16012, which identifies the testing that is accepted, that you must follow for it to be recognised under BR443.
Yeah.
So, and usable under building regs. We have always followed that guideline and we've always tested our products in that way. The distinction on the hot box test, the guarded hot box, which is the international standard ISO 8990, is a large piece of kit, a huge apparatus where you can actually make full assemblies of wall structures, roof structures, etc. You test the wall structure, you calculate back the impact of every element within that, and you get a thermal value. It's a very time-consuming and expensive way of testing. And if you consider there's no hot box available in the UK now for companies to utilise, so all testing would have to be done in Europe. And I know of 2 hot boxes, one in Germany, one in Lithuania. There are 3 elements within what sometimes are generically referred to as hot boxes, because all the equipment used is box shaped when all's said and done. So why not call it a hot box? But those are international standards of testing: hot plate, heat flow meter, or the guarded hot box. You'll probably find all manufacturers now using either the hot plate or the heat flow meter, which is to ISO 8301 or 8302, and it all sits into this it sits into EN 12667 for products over 20 mil in thickness, which most multi-layer foils are, and is all subsumed within EN 16012. So there is a recognized route to testing and outputs, i.e. thermal performance, that we can use in the marketplace that are recognized and approved. And that, when all said and done, is everybody is building to hit a particular target. They want to utilize products that they know are accredited in the right way. And as I can certainly say for SuperFOIL, that's where we sit.
Okay, so if we were doing something like a loft conversion, for instance, and we found we didn't have enough room, we haven't got enough headroom in that loft conversion to get the amount of required conventional insulation into that loft conversion, your products, your SuperFOIL products, would give us an alternative to be able to achieve the same standard, yeah?
Yeah, you can utilize a multi-layer foil to hit any of the UK standards. 0.13, 0.11, 0.18, wherever you need to be on the scale in a roof. The same in a wall, 0.28, 0.18, or if you want to be lower. And the same can be said as well in floors. But floors, we tend to look at the multi-layer foils primarily in suspended timber floors. One of the things that people have always aimed for is we want to use one product to achieve our solution. Yes, you can achieve your solution using one product. Historically, it's been mineral wool or whatever. But as building regs become tighter and tighter, thermal values, the target values are lowering, and lowering, then all that means is that you are having to include more and more of that same traditional insulation.
Okay.
More and more insulation means you've got to look at more and more timber to accommodate it, which, in this day where we are very much focused on sustainability, etc., then the fact that we are going to need bigger timbers, heavier overall build weights, etc., doesn't seem quite right. And moving everything like that around in large volumes means more wagons, etc. Whereas if you're working with a multi-layer foil, one layer of foil on its own, with the products that are available in the market, and say we have the highest performing foils, in a roof, there isn't a product that will hit the UK building reg of 0.18 on its own. It would be either in combination, i.e. with another layer of foil, so 2 layers of a multi-layer foil product, or it can be used in combination with traditional insulation products.
Like, for instance, some kind of fiberglass quilt in there.
You could use it with fiberglass. You could use it with PIR, with PUR, with most traditional insulations.
Right. So on a typical loft conversion, for example, you touched on this earlier, talking about the air gap. But I understand that when you put that multifoil in, supposing we're putting that over the existing rafters, we're not adding the depth of rafter. Yeah. We're going to staple that or nail that or fix that to the existing rafters and put a counterbatten on there of some sort to achieve an air gap, a sealed air gap within the warm side of the building, if you like. and then we're going to put a vapor barrier on top of that. Would that be right?
Not necessary, because SuperFOIL products are warm side. The products that we generally use on the warm side of the roof. So SF19 plus SF40, SF60, both outer layers are high performance vapor check layers.
Oh, okay. So you would be taping the joint there?
You overlap the joints.
Yeah.
And the installation guide will tell you overlap 50 to 75 mil, and then tape that joint. And that tape isn't a structural tape. It's not there to fix the product. It's there to maintain the air tightness. So we're making sure everything is closed, because these are all vapor check layers, high performance vapor check layers. They will they are air barriers as well.
Oh, okay. So that would be a loft conversion. Now, if anybody was looking to upgrade their insulation in their loft, for example, I've got a job I'm looking at the moment which has just got about 50 mil of quilt in there, and it really needs a lot more adding to it. We're thinking we're going to have to add at least another 150 millimeter quilt to that, or the alternative is that we could go the multifoil. Have you got a product that would suit that?
You can mix and match with that. What I would say, and the way I approach most tasks, many people are coming to us with this requirement, their own urgency to improve their insulation, and particularly at ceiling level. A lot of older properties have got minimal insulation at ceiling level, and they're also, in a lot of older properties, we're only looking at 100 mil rafters. Yeah. So we've got very little latitude. And the other thing that's there is generally no vapor check element installed. The ceiling. And you've got a cold air space above, so we need to do something about it. In those sort of instances, I always start to talk to people about future-proofing their property. In terms of, it's a case, you might not utilize the loft space other than storage currently, but if we look at over the past 5-10 years, the preponderance of people are looking at increasing their amount of living space in their existing property than actually moving. There's greater bronze. So future proofing. So I would start to say, don't add any more at ceiling level. In fact, we can do away with it in its entirety. Let's take things onto the sloping roof. Now, in traditional cut roofs, it's very easy. Truss roofs are a little bit more awkward, but if you room in roof trusses, etc., make life a little bit easier. In terms of taking your insulation onto rafter level, sloping roof, it just gives you that more flexibility in the building.
Yeah, so we're warming up the loft space basically. So any plumbing in there is safe and so on. And I suppose if people are keeping things in the loft that they care about, even if they're not living in it, if they're just using it for storage, and having a warmer loft that may be beneficial to them for that.
Even small things like that. Yes.
Yeah. The next thing that slightly concerns me, or greatly concerns me here, is the problem of condensation, because we've done quite a lot of condensation in loft spaces. That is a problem for people. Are we going to be making our life hard? We're going to be making trouble for ourselves with this or not?
No, as we say, both outer layers of all 19 plus 40 and 60 are high performance vapor check layers. So this becomes the warm face. Okay. And you're overlapping and taping joints. You're sealing that foil to the wall plate, to the ridge beam or whatever, and you're making sure that every joint is taped and fixed properly.
Okay. So and I guess there'd be an air gap. There'd be an air gap on the outside of that foil anyway.
Correct.
So it would act as it always has done in that case.
All right, so that ventilation area. Yeah.
I think that kind of, it doesn't take care of, but we've touched upon roofs and so on. What about somebody who's got a house with a solid 9-inch wall and is looking to increase the insulation here? Now we get loads and loads of these. Obviously, there's external wall insulation. You can do that. That's quite a big job. But if somebody wants to add some insulation to that wall without increasing the depth of that wall too much and losing living space and order disruption, is there something that you can do with your products there?
again, this is where you're looking at, 9-inch solid brick wall. This, that is a common element of the built environment in the UK. 9-inch solid walls are common. And I'm sure as we move, into Eco 4, which is hits the ground in April 22, solid brick wall buildings are central in that sort of initiative. But the way we cope with the solid brick wall, if we're talking 95 mil of floor space as a minimum that we can achieve that building reg value or target 0.3 or 0.28.
Yeah. Well, so sorry, let me just clarify that. So what you're saying is we're going to lose 95 millimeters off the floor space to achieve. So in other words, we're pushing the walls out around the whole of the room. The outside walls, we're only worried about the outside walls after all. And we're going to be losing, say, 95 mil there. Yeah.
95 or 4 inches an almond.
Yeah. So can you just, without giving a spec, because I know you need to do these things on an individual basis and so on and give people proper technical advice for their particular example, if you like, or their particular building project. If somebody's looking to increase the insulation value, even if they're not trying to get it up to modern standards, but they want to do something to increase their insulation, what kind of things would they do on a solid wall? Would they batten it out and then put the foil on? Or?
The easiest solution is your first layer is a layer of battens, minimum 38 by 50 mil battens onto your external wall. 600 centers is fine because remember, this isn't structural, so we've got no issues there. At 600 centers, SuperFOIL SF19 plus, stapled across the face of that, joints overlapped and taped, finished top bottom edge. Counter batten, again, a 38 by 50.
That's for this essential airspace.
To create the airspace either side.
Yeah.
Those airspaces also provide you the opportunity to run cables, etc. So you've got it.
Okay.
You've got that there.
So long as we're not piercing that vapour barrier, we're laughing. We can do all that on the
and if we do
side.
Pierce it, then as long as we tape around it, make sure everything is tight around, we're good to go. But just to sort of people start to think, well, how? SF19 Plus, for example, is a 45 mil thick product. It will compress where it's fixed between two battens. Okay. It will compress down to around about 6 mil. That 45 mil. It's continuous though, so that bridge is still broken. We haven't got a cold bridge. It's continuous. And then we find that 45 mil of material bellies out in between those two battens.
Got it.
Okay.
So should we fix it a little bit loose there or not? Or should we stretch it tightly across the band?
The thing you should install it as it comes off the roll.
Okay.
Rather than stretch it taut, because if you think you pull and the outer material is fairly robust. Okay. It won't tear easily. It's
hard to cut. I've tried it.
It's pretty robust. Okay. So if you pull it tight, that 45 mil of product is pushed all forward.
Got it.
So you're actually, if you're working with a 38 by 50 batten and you've got that taut back layer of the foil, then it's got nowhere to go apart from forward. But you haven't got 45 mil of space to fit it in. So it's about installing it to its natural length, fixing it, and then using the correct size battens.
Okay.
Creating the airspace adds significantly, because that solution on a 9-inch solid brick wall will give you a U value of 0.29.
Well, that's not too bad, is it? That's getting up towards what would be an old-fashioned cavity wall without the insulation, isn't it?
It's in terms of renovations, if you are under the Eco label and you're getting support with your insulation installs, etc., then 0.3 is the target that they're looking at.
Yeah, that's pretty good.
If it is an extension project, so if you're extending onto your existing property, the target's 0.28.
Yeah.
So
you're not bad then, are you?
We're pretty good at 0.29
very
and
close.
only losing 95 mil of space.
Yeah, I'll just explain to people that may not know too much about this, that the lower figure is the better figure. The one we're looking for is to try and get down to, under 1 if we could, that kind of thing. But obviously that's very hard to do.
This is where some of the confusion comes in insulation and people's understanding. Products have R values. They have thermal resistances. They have an R value. They don't have U values.
No.
The only time they achieve a U value is when they're part of the overall structure, where every element in that structure has a thermal resistance. Yeah. And so the U value is worked out by dividing 1 by the sum of all the R's.
Yeah, okay.
Which gives you the U value. And as we are looking at more energy saving legislation, building regs is part of that energy saving. So our building regs values are becoming tighter and tighter. So that U value of 0.28, for example, which is extension or renovation project, for a new build, it's 0.18. So it's significantly lower. So needing more insulation.
Okay, so that's the roofs we've talked about. We've talked about the walls, and the last one that I really want to talk about, because loads and loads of people are asking us about this, is can they do anything to warm up their floor? Now, we forget the solid concrete floor in this scenario, and we'll just look at people that have got drafty old floors. They've got Victorian house, they've got air bricks going underneath, so there's a howling gale going under their floor, and they can just feel they have to, on a cold winter's evening, they're tucking their feet under them on the sofa to keep them off the floor because it's freezing. Yeah. So what can you do? What can you do about that? Anything?
Well, there are 2 ways you can approach it. One of the most successful uses of a foil is in a downward airflow, because that low emissivity surface, the top surface of the foil, and that gives you a really good rate of return for an airspace in a downward airflow. One thing I should say, in the use of the value of the multi-layer foil, the core value of the multi-layer foil doesn't change when you use it in either a roof, a wall, or a floor.
Oh, okay, because that's the R value.
That's the core thermal resistance. Yeah. And if you're selecting a foil product, then always look at the core R value. And look for as high a core R value as you can find. Okay. So the core value stays the same and never changes wherever you use it. The thing that changes is the value of the airspace. The value in a vertical airflow is not as good as a value in a horizontal airflow. So the airspace value in a roof is less than what you would get in a wall. Thermally.
Okay, yeah.
And the wall is significantly less than what you get in a floor.
Oh, so really?
Insulating that floor gives you, with a multi-layer foil, will give you an excellent return in terms of performance.
Good. And hopefully in terms of your investment in time and money as well.
Yeah.
So it's really, because whenever we talk about this, we say to people, insulate your lofts first. That's the first thing you should do, is insulate your loft. But actually, although that's true, that holds true, the next thing we want to be looking at, if we've got those drafty old wooden floors, is the floor, really.
Yeah, let's address the floor. But you say roof, walls and floor, if you're addressing all 3, then, you're certainly on the right track. But, a lot of conversions, etc., involve floors coming up, suspended timber floors, the floorboards are coming up, and that is the easiest solution to deal with. When floorboards are up, we just drape the SF19 plus wood in a floor, and there is a slight. It's easy for us to give you a solution more or less direct in return for your wall and roof scenario. But when it comes to the floor, it's a more complicated calculation, because we have to take the area of the floor as well as the impact of the external walls on that floor. Yeah. So it's a more complicated calculation. So we have to come up with a perimeter to area ratio, a PA ratio.
Yes. Yeah.
So if you were looking at, for example, a PA ratio of 0.4, and again, it's all below, the lower the PA ratio, if we were to drape SF19 plus over the top of the joist, again, overlap, tape the joints, staple to the top side of the joist. You can either staple the foil to the inner side of the joist, or you can batten along the inner face of the joist to fix it in place. Create a 50 mil airspace between the underside of the floorboard and the top of the foil. So you depress it into that cavity that you've got between the joists. You can achieve a U value of 0.23, which is pretty good. Yeah, you're starting to get right into where you need to be. If you then add all the other bits and pieces in of the floor build-up, you'll get to be like at least 0.22, and 0.22 is building regs.
In
renovation and extension.
Yeah, that's well worth having. I just mentioned you do still need to seal those joints when you drape it over. We're still looking at taping that, which is tricky sometimes when you're draping it to apply that tape. Maybe the thing to do is stretch it out, apply the tape, and then drape it down into the floor if you can. But that's one way. But again, depending on SuperFOIL products come in rolls, 1.2 meters by 10 or 1.5 meters by 10. So 10 meter lengths, a 10 meter length is often more likely you will cut the length than use it as a 10 meter. Got it. Okay.
Yeah. So we're hoping that they will be continuous lengths. So you haven't got lots of joints, etc.
Got it. So we're only talking about the okay, I understand. So maybe in a room you might get 2-3 joints there, and that's not too onerous. So we staple that down onto the thing and we put the floorboards back over the top of it.
Yeah, scraping the product, so we've got that 50 mil airspace, and then we've got that really good performance.
And we still need our underfloor ventilation going through. We don't block up our air bricks.
We're not blocking our air bricks. No.
We leave those going.
Everything is there. Timbers are aired, etc. Yeah.
Now, obviously, there are going to be a lot of people watching this who are going to be excited by this prospect, I'd say, of being warmer. And because, I mean, it's not only about saving money or, helping the planet here. We're actually talking about people's thermal comfort. We're talking about it feeling better, a nicer place to live in, when it's not freezing cold, and especially when the wind's blowing. So there'd be a lot of people, I think, who would be interested in this. What can they now do to get more information, to get more technical help? Because obviously your time is limited. You can't talk to every single person, but presumably...
We're trying to.
Presumably you got a website where people can do a few calculations and so on, yeah?
Yeah, there is a website, superfoil.co.uk, and under services is a U-value calculator. There's also a request form on there. You can request samples, you can request U-value calcs, you can ring us direct. We have a team that are there Monday to Friday working on calcs right through the week and providing assistance to all levels of user. It could be the end user, it could be the contractor, architects, building control. We get calls from all aspects.
So what I'd like to say then, just by way of closing this, is that multifoils do work, and it's really a question of applying them properly. And not just, if you're a builder thinking, I can just stick this multifoil up because it says it's equivalent to that, and not taking care of those details is an absolute no-no. You've got to do the job right. Do you actually give installation advice? The things
we haven't. You'll find an installation guide on the website as well. And I say we're more than happy. We have a team of agents out in the field who can give advice as well. But primarily for technical, we're here on the end of a phone, on email, available for everybody to access.
Thanks for coming on, and hopefully this will be great interest to our viewers.
No, happy. Thanks for the invitation, Roger. Really appreciate that. And we look forward to hearing from people.